This is a companion video for Exercise 7 of Architectural Simulations. This week we'll be covering how to add electric lighting and tubular skylights to your design models. Before we do that, let's remind ourselves what we're doing here. We're learning a set of simulation workflows that should be used together and simultaneously as part of an iterative design approach that will keep your form in line with whatever performance-based metrics that you have defined in your program. So for example, this is a little massing model we used 1 week. We did various simulations, some of which were daylighting based. And so we had a basic floor plan that had some variation to it. And we tried a variety of daylighting strategies. We added shading of different kinds for different purposes, and came up with some options that were down and dirty and quick, and then were based on the site and the context. And the metrics we were thinking about were LEED 4.1 related, but that's just a certification. Really, what we were saying was, do we have enough lighting, spatial daylight autonomy, and do we have too much in some places? And of course, we start off with way too much, and then we usually are able to make some decisions quickly to get us more in line with the goals of the certification and of how much and of having good daylighting in the space. But then we have some spaces that are underserved or that cannot be daylit with side lightings, because all we've been talking about so far is side lighting. So for example, these meeting rooms here are underserved, and this core, which would be where the elevators, stairs, mechanical rooms, other storage would be. And so how are we going to light this? And how are we going to do it in a way that's connected to our daylighting strategy and is energy efficient? And, even a stair core should be a pleasant place for people to be, right? So one metric we really didn't talk about much was the average lux. And that's just telling us the average amount of light or illumination on the work surface. Remember, we defined a work surface that was a certain height above the floor. In this case, that was a LEED requirement or a LEED setting. But if this were a gym, for example, our work surface would be the floor, so this would move around and we can adjust it. Any one of these single floor plates could be changed. Okay, so we're going to use these lux values for electric lighting and tubular skylights to see how we can add them to supplement our daylighting strategy or our side lit daylighting strategy. So let's start with just a very simple model. The point being, the reason I just went through all that is, remember, it's a good idea to do these first simulations in a very controlled environment, like a lab, like an experiment. But you should always immediately start applying them to the larger project because they're not standalone. They're really sort of meaningless by themselves. But what if we've got a floor plan, walls, interior partitions, a ceiling, and a roof, because we're going to have skylights, we need a thickness to our roof. And basically, this is a box, right? So you can think of it as a lab. I mean, this is a little daylighting lab that we're setting up in our model in Rhino. So I've got 3 rooms: a lab, a lounge, and an office, and they all have different lux values. Why is that true? I have a link in the assignment to a chart. This is just a chart. There's nothing magic about this. It's just making a point that we have different target lux values for different types of activity. So, this conference room, we're saying 300 to 500 lux. Let's see. A laboratory might have 750 to 1200. So there's a variety, and that's where these numbers are coming from. And these are the targets that we need to, in this case, try to design electric lighting that will meet these targets. So how do we do that? The first thing is that the first step is which uh, simulation workflow are we going to use for electric lighting. We can use a point-in-time illuminance. Why is that? Because we can essentially turn off the sun. So if we set it for any day to midnight or nighttime when there's no sun, then the only illumination in the building will be from our electric lights. So that's what we're going to set it for. You'll remember that a point-in-time illuminance simulation we have layers on that we want to have on in the simulation, and we apply materials to them. In this case, there's not going to be any glazing, so they're all solid materials. You'll remember how to do that from other assignments. And now all we need to do is add. Oh, well, then we need a a place for the light to hit. That's our work planes. This is the same thing we've done before too. So all we need now is to add lights. Hopefully, from environmental systems 2 or some other class that you took if you're a graduate student, um, you'll have some memory of how electric lighting works. We're going to add luminaires here. We click on that, the typical workflow in Climate Studio, right? We have this on the left side. We can add what we want to add. Um, what is a luminaire? A luminaire is a light fixture. So light bulbs, you could have 10 light bulbs in a luminaire. So it's just a unit of lighting. Um, in Climate Studio, we have a set of, it's not a huge basic library, but it's plenty for what we need, and we could add to this. Um, let's look at the metrics here. First, power multiplier is just whatever remember this about Climate Studio, a real advantage of it is that we can quickly customize. So if we've already chosen lights and we think, I just want this to be twice as bright, we can come in here and change the power multiplier and it will adjust these other variables. Then we have total luminous output and maximum luminous intensity. What are those? Well, first thing you can do is click on information and go to the Climate Studio help file. It's good to read these, and it talks about luminous output and maximum luminous intensity. These are not exactly the terms that I'm used to seeing. Um, you'll have seen this chart before. I'm pretty sure you'll see it when you're studying for the NCARBs. Um, the basic idea is that we have a light source and it's putting out light in a sphere coming off of it, and then wherever we're trying to light, like our work surface or where our eye is light in a direction. So that's the two different varieties here. Um, and so the output in all directions is called the luminous flux, and that's in lumens. And then the luminous intensity is the amount in a direction, and that's also in lumens. So that is, and just, if that's confusing, just go back and look at it. It's really pretty simple. But these terms, I agree, are not, not the clearest all the time. But the point is that this is output um, from the sphere, and this is output in a specific direction. And with these metrics in mind, do these horizontal and vertical sections make sense down here? So the horizontal section, that's this little circle is showing us how widely this light is going to be dispersed horizontally. And then vertically, we're seeing, so typically, the light is right here in the middle, and so we have some light going up and some light coming down. So some going toward the ceiling, some coming down toward the floor. Um, and so we notice that then the part going down is a subset of or small compared to the amount going up. Now, this is candelas and this is lumens. I'm not even going to talk about it. Let's just think of these as um, relative to one another right now. Okay, so let's now pick a different light. Let's just pick a light bulb. Um, Actually, let's not pick a light bulb. Let's pick um, a circular downlight because this will make my point better. Um, So now we see we have a light that's got a horizontal spread represented by this graph, and then all the light going down toward the floor. So in this case, then we have relatively, because these are not the same units, we have a lot of light going down relative to the amount that's coming out, right? So that's the opposite of what we had before, and that's because we have most of the light or all the light coming down from the light source toward the floor. So these are the two main things you're thinking about. If you think about it, so what's this is going to be more directional. It's going to be more of a not a. I'm not saying this is a pen spot, but it's going to be just light directly toward the floor. The one we had before, actually that wasn't it. This was it, and we see that relatively we have a lot more total output than what's going in a direction. So that's what and what would be the point here? So we're going to get some light bouncing off the ceiling, which has it's just a different effect and has a different effect on humans and on the type of work that can be done using it. All right, so let's just go ahead and let's pick a downlight to simplify it. And I'm just going to place it in my model. I'll just set it somewhere. So here's our light. So I'm just going to move it into place where it's right below the ceiling. And let's just make up some kind of placement. I'm going to start here, and I'm going to now array these into the room. So I'm going to use the array command. Select the object to array. Let's do a 3 in the X and 6 in the Y. I already did this, that's why I didn't just set it. Only 1 in the Z, because we only want one light. And a quick way of doing this is just to select and pull the array out. So there are our lights. Let's run a simulation. So by the way, you can see the results here because I have values on. And so what results did we get here? Still running, but it's not changing very much. Let's just see. I'm going to let it go one more pass. Um, didn't change hardly at all. I'd probably let this keep going, but since this is just an example, I'm not going to. I'm going to stop it. And so we said that our target is 750 to 1200. We're at 30, so we're really high here. But and this might be you don't typically use pendants in a lab, right? Or downlights like this, and this is why you're not getting an even disbursement of light, and that's why the color is helping us. We can really see that there's a weakness here. So let's try something else. If I come back and edit this, by the way, these other lights are here because I've already run some simulations in this model. Let's edit this and change these to something else. Run the simulation. And you can already see we're getting very different results here, right? Um, let me let it run for, oh, actually, I'm not sure if it's actually started yet. Um, I wonder if that's an anomaly. That's weird. I'm going to let it, let's just say that's it. I don't, because I'm not trying to be accurate right now. I'm just trying to show you how it works. So I've let it run for a while, I'm stopping it. Um, so now we've got, let's compare the two. Very different, right? We can tell both from the colors and from our settings, our output numbers. Let's now go in and edit this one more time, and we can change this power multiplier. I'm going to do it times 2, update, run, and we'll get a different result. So that's the basic workflow. Um, we can also change the materials on, the walls or the ceiling. Like for example, this. Oh, and by the way, this is a good point. Let's look at this for a second. I'll leave this to you to play around with, but it doesn't seem like this is where that light should be sitting, right? Like I set the pendant where the base of the light was right at the ceiling. Well, these probably need to come down, right? And we can see that in fact we are getting um, a lot more light when we moved our fixture down to let that reflection off the ceiling happen as it's designed to do. So this is a pretty quick workflow. Just make sure you experiment and learn about it. Change materials in the ceilings and the walls. See, that's really interesting in terms of your projects. Like, um, what will materials choices? How will they affect the amount of light in the room? And again, this is in our little controlled box. That's a good way to make that to have that experiment or to do that experiment, and then apply it whatever you're learning to um, your project. And so the last thing I'm going to show you in this context then is just the same model. I did separate lighting choices for all 3 rooms because remember, we have these different lux targets. And then, so what were my results? Or how did I started with a baseline, um, and then I made adjustments to each light. Each different light in each different space. For example, in this one, I just increased the multiplier by 3. I think in this one, I made this one shorter, and I probably moved the placement of these. The point being that so you can just quickly move that around and compare outputs. Um, then I experimented with. Let's just look in here. Um, I changed the RViz of the exterior walls. Remember that we have these specs for our materials, and the visible reflectance is what we're talking about here. And so um, this material that's chosen right now is a very high. This is the whiteboard wall. It's very reflective. So I started with, go back to this. I started with a reflectance. Basically, I think it was black, like a black body. If this is 0.34%. And then I changed the walls to a 92% reflection, so quite a bit more. It has a significant effect, but that's a drastic change in the wall color. But still, the point is that the walls, and then if I did the ceiling, especially if I had, like in the other model where I had that pattern where part of the light's going up to the ceiling, I could make a big difference by choosing ceiling materials. Okay, so that's electric lights. Let's talk about adding the option of adding tubular skylights. Um, so what are they? So tubular skylights are, so if you think about it, like, this skylight here is going to, that's why there's blinds on them. There's, in the summer, a huge amount of light coming in through overhead skylights. So they can be very inefficient or ineffectual, like, this one. Um, that's going to really overheat in the summer. Um, you're going to get heat loss through it in the winter, and you'll get some gain, but you won't really be able to spread it or control it. So overhead skylights are problematic, and so this really cool product has been developed called a tubular skylight, which is basically has a diffuser, this part up here, and then a reflective tube that can bend. So like this is, an angled tube. So they got the reflector up here, the diffuser, this angled tube, and then basically a light fixture at the bottom, or an aperture that functions as a light fixture. So Climate Studio partnered with Velux, I think it was. No, maybe it's another company. Anyway, they partnered with somebody, and inside of Climate Studio, there are still running that simulation. Um, there is a library of tubular skylights that you can add. So, um, why would we do this? If we go back to this picture, well, no, let's go to this model. Like I was saying here, and I could add um, electric lighting in my core. I can add electric lighting if I don't have enough here, like we're saying, that um, maybe there's not enough um, daylighting in some of these conference rooms, and definitely there's nothing, since we don't have any windows in this core. There's none in here. We could use energy and electric lighting in that space, or we could bring a um, a tubular skylight in from the roof down to whatever floor we wanted to, right? As long as we had a chase that we could send it through. So it can be it's a type of daylighting. So let's just look at how we add them. So we're going to use, in this case, a daylight availability. You could use point in time. If you use a point in time, then I would pick two different times, one in the winter, one in the summer. Makes more sense to me to use just the lead daylight availability, and then we can use the lux measurement from there. And we got the advantage that everything's already set up here, right? So we've got all our materials in place. So we can change them if we want to. We have our visible areas. Let me actually turn off my simulations. We have our work planes, um, which are the areas, right? And so all we have to do is add some tubular skylights. Um, so let's add. And what are our, you know, we've got a picture of the basic unit, but what do we really care about here? Um, the VT annual, so that's the amount. Let's just look at what it says. Yearly average visible transmittance. We've been talking about that, right? So basically, we're saying this has it's letting in half of the possible daylighting. That's pretty good. Let's see what the others are. They're all, they're all kind of around that range. But anyway, that'd be one thing to look at, see if we could get more of that, higher, or if we needed more once we run a simulation, can we come and find something that has a higher VT? And then we have preset tube lengths. We can change those. But anyway, these are things you can mess around with, and once you've added a skylight. So let's just add something to see what happens. So I'm going to add this first one. Um, Basically, the idea is that you don't want to scale them. That's all this is saying. They're added as a block. If you've ever used blocks in Rhino, it's a way of having components. Um, Remember, this layer is created over here. I typically move mine to other layers, but you have to have the Climate Studio tubular devices is what's added by the program. Let's select the skylight, move it into place. This is a little confusing to me, so let's just look at it. So first, I'm going to select just the bottom. Oops, sorry. And I'm going to move it. Let's zoom in and see what that says. So you can see it says ceiling and roof. And this is what I find confusing. We'll talk about it in a second. The ceiling is pretty clear. And this is the point. Let me get out of this again. If I just select this, I do not want to scale it. I don't want to pull on that. That's going to create an error. I want to double click on it, get the block, um, and now move it. And so that's kind of clear. That's where my ceiling is. It says ceiling. Um, okay. But up here, this is what I'm moving to the roof surface. Oops. And there's this other part of the component down here that says roof. I'm not quite sure why that's the configuration. This works with the dome sitting on top of the roof. We can play with it and talk about it. Um, this is if if you look at Climate Studio's example videos, this is how they do it. Um, okay, so we have a single skylight, and now we're going to do the same thing we did before. We're going to move it where we want to. And one thing I might do here is, let's see if I turn back on my electric skylights. Let me just put them in the same place. And then I'm really comparing apples to apples. If I, because then I can say, well, I really don't, I only need the lighting on at night, and that would have another effect on my, my controls. Let me get this a little bit better. Okay, so here's the simulation. Um, it's been running for a little bit. I'll just stop it. I'm nowhere near my targets, so I could go in and I can edit this. So if I edit this and say, what am I? I'm at my aperture right now was what? The diffuser is about a foot. So let me see if I can find something much larger than that. Just again, I'm just going to throw it in here. Something, 2.5 feet should be a big difference. Um, Run that. Yeah, and we can already see that's a massive difference, way too much. So you can see they're really essentially the same as electric lights. And so then there again, I can do the same kind of iteration, and I can, you know, keep editing these, adjusting these, the size or the number to where I get the outputs I want for my tubular skylights, and then I can add electric lights in addition to make up any deficiencies. And then, of course, the point is that we want to bring that into our more major model or our actual design model and apply what we've learned from this simulation workflow. All right, that's it. See you in class.